Plasma cutting is a process that is used to cut steel and other metals of different thicknesses using a plasma torch. In this process, an inert gas is blown at high speed out of a nozzle. At the same time, an electrical arc is formed through that gas from the nozzle to the surface being cut, turning some of that gas to plasma. The plasma is sufficiently hot to melt the metal being cut and moves sufficiently fast to blow molten metal away from the cut process. The HF-type plasma cutting machine uses a high-frequency, high-voltage spark to ionize the air through the torch head and initiate an arc. These do not require the torch to be in contact with the job material when starting, and so are suitable for applications involving computer numerical controlled cutting. More basic machines require tip contact with the parent metal to start, and then gap separation can occur similar to DC-type TIG welders. These more basic type cutters are more susceptible to contact tip and shield damage on starting. The pilot arcade type uses a two-cycle approach to producing plasma, avoiding the need for initial contact. First, a high-voltage, low-current circuit is used to initialize a very small high-intensity spark within the torch body, thereby generating a small pocket of plasma gas. This is referred to as the pilot arc. The pilot arc has a return electrical path built into the torch head. The pilot arc will maintain itself until it is brought into proximity of the workpiece where it ignites the main plasma cutting arc. Plasma arcs are extremely hot and are in the range of 25,000 degrees Celsius. Plasma is an effective means of cutting thin and thick materials alike. Handheld torches can usually cut up to 38 mm thick steel plate, and stronger computer-controlled torches can cut steel up to 150 mm thick. Since plasma cutters produce a very hot and very localized cone to cut with, they are extremely useful for cutting sheet metal in curved or angled shapes. History. Plasma cutting grew out of plasma welding in the 1960s, and emerged as a very productive way to cut sheet metal and plate in the 1980s. It had the advantages over traditional metal against metal cutting of producing no metal chips, giving accurate cuts, and producing a cleaner edge than Aussie fuel cutting. Early plasma cutters were large, somewhat slow and expensive and, therefore, tended to be dedicated to repeating cutting patterns in a mass production mode. As with other machine tools, CNC technology was applied to plasma cutting machines in the late 1980s into the 1990s, giving plasma cutting machines greater flexibility to cut diverse shapes on demand based on a set of instructions that were programmed into the machine's numerical control. These CNC plasma cutting machines were, however, generally limited to cutting patterns and parts in flat sheets of steel, using only two axes of motion. Safety, proper eye protection and face shields are needed to prevent eye damage called arc eye as well as damage from debris, as per arc welding. It is recommended to use green lens shade number 8 or number 9 safety glasses for cutting to prevent the retinas from being flashed, or burned. OSHA recommends a shade 8 for arc current less than 300, but notes that these values apply where the actual arc is clearly seen. Experience has shown that lighter filters may be used when the arc is hidden by the workpiece. Lincoln Electric, a manufacturer of plasma cutting equipment, says, typically a darkness shade of number 7 to number 9 is acceptable. Longevity Global, Incorporated, another manufacturer, offers this more specific table for eye protection for plasma arcade cutting at lower amperages. Leather gloves, apron and jacket are also recommended to prevent burns from sparks and debris. Starting methods. Plasma cutters use a number of methods to start the arc. In some units, the arc is created by putting the torch in contact with the workpiece. Some cutters use a high-voltage, high-frequency circuit to start the arc. This method has a number of disadvantages, including risk of electrocution, difficulty of repair, spark gap maintenance, and the large amount of radio frequency emissions. Plasma cutters working near sensitive electronics, such as CNC hardware or computers, start the pilot arc by other means. The nozzle and electrode are in contact. The nozzle is the cathode, and the electrode is the anode. When the plasma gas begins to flow, the nozzle is blown forward. A third, Less common method is capacitive discharge into the primary circuit via a silicon-controlled rectifier. Inverter plasma cutters. Analog plasma cutters, typically requiring more than 2 kilowatts, use a heavy mains frequency transformer. Inverter plasma cutters rectify the mains supply to DC, which is fed into a high-frequency transistor inverter between 10 kHz to about 200 kHz. Higher switching frequencies give greater efficiencies in the transformer, allowing its size and weight to be reduced. The transistors used were initially MOSFETs, but are now increasingly using IGBTs. With paralleled MOSFETs, if one of the transistors activates prematurely, it can lead to a cascading failure of 1/4 of the inverter. A later invention, IGBTs, are not as subject to this failure mode. IGBTs can be generally found in high-current machines where it is not possible to parallel sufficient MOSFET transistors. The switch mode topology is referred to as a dual-transistor offline forward converter. Although lighter and more powerful, some inverter plasma cutters, especially those without power factor correction, cannot be run from a generator. However, newer models have internal circuitry that allow units without power factor correction to run on light power generators. Plasma gouging. Plasma gouging is a related process, typically performed on the same equipment as plasma cutting. Instead of cutting the material, plasma gouging uses a different torch configuration, and a longer torch to workpiece distance, to blow away metal. Plasma gouging can be used in a variety of applications, including removing a weld for rework. The additional sparks generated by the process requires the operator to wear a leather shield protecting their hand and forearm. Torch leads also can be protected by a leather sheath or heavy insulation. CNC cutting methods. Some plasma cutter manufacturers build CNC cutting tables, and some have the cutter built into the table. CNC tables allow a computer to control the torch head, producing clean sharp cuts. Modern CNC plasma equipment is capable of multi-axis cutting of thick material, allowing opportunities for complex welding seams that are not possible otherwise. For thinner material, plasma cutting is being progressively replaced by laser cutting, due mainly to the laser cutter's superior hole cutting abilities. A specialized use of CNC plasma cutters has been in the HVAC industry. Software processes information on ductwork and creates flat patterns to be cut on the cutting table by the plasma torch. This technology has enormously increased productivity within the industry since its introduction in the early 1980s. In recent years there has been even more development. Traditionally the machine's cutting tables were horizontal, but now vertical CNC plasma cutting machines are available, providing for a smaller footprint, increased flexibility, optimum safety and faster operation. New technology. In the past decade, plasma torch manufacturers have engineered new models with a smaller nozzle and a thinner plasma arc. This allows near laser precision on plasma cut edges. Several manufacturers have combined precision CNC control with these torches to allow fabricators to produce parts that require little or no finishing. Costs. Plasma torches were once quite expensive. For this reason they were usually only found in professional welding shops and very well-stocked private garages and shops. However, modern plasma torches are becoming cheaper, and now are within the price range of many hobbyists. Older units may be very heavy, but still portable, while some newer ones with inverter technology weigh only a little, yet equal or exceed the capacities of older ones. See also, laser cutting, air carbon arc cutting, plasma arc welding, water jet cutter, welding, list of plasma articles, references. External links, How Stuff Works on Plasma Cutting, Plasma Cutter Safe Work Method Statement.